every cloud, every rainstorm is part of a never-ending cycle on which all life depends. Every bubbling spring, every rushing torrent, every smooth-flowing river is a part of this life-sustaining cycle. In this cycle, water from the broad expanse of ocean evaporates and forms clouds. From clouds to earth, it falls as rain. Finding its way into streams and rivers, this water flows back to the sea. Let us examine this cycle again more closely. By evaporation, tiny water particles escape from water surfaces. In the air, these particles may come together and form droplets that appear as clouds. These clouds may grow in size. Droplets in the clouds may combine to form larger drops that fall to the earth as rain. Eventually, most of the rainwater joins in rivers and flows back to the sea. This continuous circulation of water goes on and on. This is the water cycle. Let us consider the evaporation phase of this cycle. Water, like all matter, is made up of extremely small particles called molecules. These molecules are always in motion. Some of the faster-moving molecules escape from the surface and enter the air above. This is evaporation. A few of them return. As the sun warms the water, the molecules move faster, and so more of them escape. We say that the space above the water is saturated when as many water molecules return to the water as leave it. If the temperature of the space above the water rises, the number of molecules entering this space again exceeds the number returning, until once more a balance occurs, producing saturation. If the temperature of the space falls, some of the molecules form droplets of water. This is condensation. This condensation may form clouds close to the surface of the earth. Such clouds we call fog. Ordinarily, however, when we speak of clouds, we mean those that form higher in the sky. The formation of these clouds depends upon the movement of air. Warm air near the Earth's surface upward because it is less dense than cold air. As a current of warm air rises, the pressure of the atmosphere upon it decreases and the air expands and cools. This cooling causes the moisture in the air to condense, forming clouds, and sometimes producing local showers. When a large mass of cold air, as represented here at the right, meets a large mass of warmer air, as represented at the left, the warmer air rises, expands, and cools. Clouds begin to form, and a storm may result. Here we see such a storm developing. This kind of storm may extend over a broad geographical front. Most of the rain that falls to the earth runs off the surface of the ground as soon as it falls. Tiny trickles of water merge into rivulets. The rivulets flow along, sometimes trickling over rocks, and sometimes tumbling down hillsides as miniature waterfalls. but always increasing in volume as the rivulets join. Mountain streams churn along their rocky ways down the steep slopes. Finally, they reach the lowlands, where they flow more slowly. The small streams flow together and form the larger rivers. The rivers flow onward to the sea. Some of the water that falls to earth sinks into the ground and seeps slowly downward through the porous layers until it reaches a depth where the soil is already saturated. The downward moving water raises the level of this saturated zone. The upper level of this saturated zone we call the water table. Thus, we may find the water table below the surface of the ground. But where the water table is above the ground, we find lakes and swamps. At all times, there are some molecules of water that rise to the surface of the ground and escape by evaporation. Some of the moisture enters the roots of plants and trees. After entering through the roots, the water passes upward into the branches. Water evaporates from a plant or tree through its leaves. Large amounts of water return to the air in this way. We have seen that part of the rainfall sinks into the soil and forms groundwater. We have also seen that great amounts of this water reach the atmosphere by evaporation from the soil and from leaves of plants. But again, most of the water that falls as rain flows through rivers to the sea. During heavy, prolonged rain, large amounts of water may reach the rivers, causing destructive floods. Man cannot control the amount of rain that falls to earth and swells the rivers. But to some extent, he can prevent floods such as these by controlling the circulation of surface water. Where growing plants cover the ground, they retard the water's flow. Most of the water then sinks into the ground instead of running off the surface. But wherever erosion has left barren ground and deep gullies, dams made of earth and brush may be used to control the flow of water. Large dams such as this one provide constant control of mighty rivers. In times of heavy rainfall, this dam holds back the floodwaters. After the threat of a flood has passed, water can be released slowly to continue its flow to the sea. We have seen how flowing water can be retarded by vegetation and by dams, great and small, for man's use as well as for his protection. But evaporation of water from the ocean, formation of clouds in the sky, precipitation of rain from the clouds, and circulation of rainwater on the earth go on and on. Without this eternal water cycle, life on Earth could not exist.